Hello, this is the video presentation that goes along with Chapter 1 of GD&T. So this is the Introduction to Dimensioning and Tolerancing. By now you should have your objective sheet, your Chapter 1 learning objective sheet printed out and in front of you as you're going through this presentation. For your reference, I've included the objectives right here, all except for objective number 7, which goes through the terms that you should know by the time you're done with this presentation. GD&T is a language that allows you to define mechanical drawings and their dimensions and the features and the relationships between the features on a mechanical part. So standards provide the needed clarity for making mechanical parts. So tolerances enable best product at the lowest cost. Tolerances result in fabrication of the intended design. And then tolerances must be correctly calculated, applied, and interpreted such that the parts go together properly. In any mass-produced part or assembly, the parts have to fit together. And then nowadays, when parts are being manufactured all over the world for assemblies, then knowing how exactly the part is being built and putting the proper tolerances and form controls on your part drawings will allow you to make parts that will go together. Once all the parts come together in assembly, everything will fit and everything will work as intended. That's why we need standards and clarity on our engineering drawings. Now, for objective 1, we're going to go through some results of incorrect tolerances. Because if you put too tight of tolerances on your parts, boy, your costs are going to go up. And you're going to limit the number of potential suppliers. Not all machining houses can handle all of those tight tolerances. And then it's also going to increase the fabrication time, again, driving up costs. Now, on the other hand, if your part tolerances are too large, your parts may not fit when you go to put them together. Assembly function would be negatively impacted, and that would lead to customer dissatisfaction, increased assembly costs, increased customer returns, and all in all, bad for business. Okay, so the development of dimensional controls. Two aspects. One is establishing a standard unit of measurement. And then 2 is establishing dimensioning and tolerancing standards. That's what this course is about. Units of measurement. Okay, GD&T doesn't really need a specific unit of measurement. You could use metric, the SI units, or the US customary units. It has no effect on how the dimensions are applied. It only affects the numerical values that are shown on the dimensions, and it affects the way the decimals are displayed. But other than that, either units are fine. So basically, typically you would have a note on the drawing that said, hey, all dimensions are in inches or all dimensions are in millimeters, and then the number of decimal places and the numerical value showed would follow that specific measuring units. I'm going to talk a little bit about the history, and really why we talk about this is there was units in the past: cubits, spans, palms, digits, roll cubits. Mankind has been trying to define these standards of distance, but they weren't very accurate and they weren't really well defined, and as what we're talking about today in terms of inches or millimeters. Here are some other different standards that were used throughout the years: Roman foots, Olympic foots, and then here we got the spans and the cubits. But again, these are not very accurate and not very well defined. So the distance standards do make a difference. Okay, look at it this way. If you have a tolerance, in this case, of plus 5/10, I call that out to 4 decimal places. I'll call that 5/10. Plus 5/10 minus nothing is a very, very tight tolerance, a very, very precise specification for the size of that bushing diameter. And the only way you can hold such a tolerance is if you could actually measure it. Okay, if you can't measure it and you don't have units defined, then you can't really hold these tolerances. So that's why it's so important to have a good standard of dimensions. Now, dimensioning and tolerancing standards has been an evolution throughout the decades. It started with Mill Standard 8A and eventually ended up where we're at now. Right now we're at ASME Y14.5 2009. I'm pretty sure your syllabus or your course objectives say ASME Y14.5M 1994 is the standard we're going to be studying, but your textbook is this 2009. We're going to talk about some of the differences between 2003 and 2009, but really it's an evolution. It's not radical changes from 94 to 2009. It's more like an evolution, and things have clarified. So we're going to talk about some of those differences as we go along in this course, but here we are for geometric dimensioning and tolerancing. We're talking about standard ASME Y14.5, 1994 through 2009. Why do we keep updating the standards? Is to keep current with industry, new methods of dimensioning and tolerancing, and to clarify current methods. And we'll touch base on a lot of these changes that the GD&T standard of as ASME Y14.5 has undergone in the last 20 years or so. Now, this is objective 4 we're going to be talking about now, design through teamwork. Really, the point here is no one individual can do it all. Okay, when we design through teamwork, we're going to be reducing cost. We're going to get the best knowledge from our experts in each field, and that could be an inspector, a machinist, and an engineer. And then we're going to have suggestions incorporated before the document is complete. And then which way we're going to develop a more perfect drawing, a more perfect design that meets the assembly requirements and meets the ultimate customer satisfaction. Here's the professions that have to deal with GD&T. As you look, it's a lot of things that you're going to be doing in your career. Top one is the designer. He's the guy who creates the drawing. Okay, and the guy who creates the drawing, he needs to know GD&T because he's putting these symbols on the drawing, and so that everybody else can follow. Then there's a manufacturing engineer. The manufacturing engineer looks at these drawings and he determines how the best way to produce these parts are. Essentially the tolerances and the level of tolerances are going to dictate, what processes are used. So he needs to understand the GD&T. Now the machinist, the guy who actually makes the parts, he's going to have to understand the GD&T. So as the parts are coming off the machine, he's going to know that the part meets the drawing. Then you have the machine programmer. That's the NC programmer. He's the guy who programs the machine that cuts the features that are defined on the drawing. And then the inspector is the guy who ultimately checks the parts against the drawings to make sure. So he needs to know the GD&T as well. And then you have the tool designer. The tool designer designs the tools and the fixtures and the cutting tools to make the part. So everybody involved in this process needs to understand GD&T. So here's the skills you need for GD&T. Applying the symbols, interpreting the symbols, explaining the requirements, and then calculating the tolerances. In this course, we're going to touch on all 4 of these topics. And I want to talk a little bit about orthographic projection. That's the 2-dimensional views that make it easier to relate one view to another. And then there's 2 methods of this. There's a first angle and a third angle. And you might be confused on that a little, but if you're ever confused, we in the U.S. mostly use the third angle projection. And there's always a symbol on an engineering drawing that tells you whether it's a first or a third angle. So look at any engineering drawing you can find, and you'll see a symbol like this or a symbol like this. First angle is what they use in Europe a lot, but third angle is what we use here in America. Just to be aware of it, because it affects how you interpret these drawings. Third angle projection, this is how the part is rotated. The views are rotated in your brain so you can understand what the drawing means. This one seems to make the most sense to me and most people in America. If you look at first angle projection, it's a little bit backwards. I'm not going to talk about too much about that, but I need you to be aware that there's two ways of showing these dimensions, these projected views on drawings. One would be the third angle projection, the other one would be the first. We primarily use the third here in America, and all drawings will have this symbol that show you what it means. That's the end of this lesson. Thank you.